Two of the main reasons of car accidents are driver distraction and inattention. So car crashes are due to something called inopportune glance. It's when the driver looks away from the forward roadway at the wrong moment. So you can see the problem with using a touch interface. To try to minimize off-road glances, we developed a hand gesture-based menu navigation system for vehicles. It's a 2x2 menu page with 4 menu items per page. We designed an experiment to evaluate different auditory feedbacks for that menu system and 2 hand recognition systems. The participant is asked to select a menu item while conducting a driving scenario on a driving simulator. To do that, we are utilizing an ICAD mini-sim driving simulator to collect driving performance data and the Tobii Pro eye tracker to study eye glance behavior. In terms of the gesture-based menu navigation, we are using a leap motion infrared camera and a screen monitor simulating the in-vehicle display. In our experiment, we are evaluating 3 types of auditory feedbacks: auditory icon, earcon, and spearcon. Auditory icons are brief sounds that are associated with objects, functions, or actions. For example, the sound of dialing for phone. Earcons are usually expressed as abstract musical tones or sound patterns and are used with structured combinations such as menus. Spearcons are brief auditory cues that are created via text-to-speech,
Bluetooth,
and then are compressed.
Bluetooth.
Now Yusheng will introduce our new hand recognition system.
Hello everyone, our new hand tracking system is using a sleep motion hand tracking device. It's using an infrared to track users' hand movement and send the data to our system to process. Based on those hand tracking data, we can allow the user to access our virtual menu interface. I know it sounds confusing. Let me show you some demo. This is the first version of our system. When the user's hand is hovering in front of the menu, the corresponding menu item will be activated and play the sound which indicates which menu item it is. And if the menu item is not what the user wants, they can hover their hand vertically or horizontally to switch to their desired menu item. Finally, they can do certain gestures, tap, or grab a fist to confirm the selection. However, this design has one potential drawback. Since all the menu items are visually created without any visual aid, the user won't be able to locate where the menu is in the physical world. If we create a visual aid, how can this system avoid any unnecessary glance by adding more visual distraction? So we come up with an idea that may solve this problem, which we called the adaptive recognition menu. Basically, it allows the user to choose where the visual menu will be. The user will do certain gestures to create a virtual menu in front of his hand. The center of the menu located at the user's index finger position. Since the user always starts at the center of the menu, the selection will be easier. Ready? Go. Select phone.